All right. So in the previous lecture, if you watched it, the part one of lecture from Unit 5, which is Advanced Material lecture, you learn how to create a material based on an unlit material, and then how you could apply several steps to create your material a special look that it changes its color according to the distance of the objects from the camera, and then how to create a dynamic material that changes color and the surface look of the material based on time. Next advanced material that you will essentially have to create one way or another in your levels is a reflexive material, or a material that you can see the reflection of the objects around it. And that is done through something that's called the cube map, and I'll show you how to do that. And then we'll see how you can set up several modules of material expressions to make your material basically present some sort of reflection, translucency, and refraction that is essential to a transparent objects or transparent materials like glass or water surfaces, as well as setting up a ripple effect on the surface of your materials. And I'll show you how that works. Now first, let's say that you want to create the reflexiveness or the reflection on your material. You can create a new material. Let's create a new material and call this material under the materials section of my advanced materials package here, and I call this my matte water 01. And so it's created, and this is my matte water 01 that I have. Now to make your material translucent and also to make it reflexive, we would need to change the blend mode and lighting mode of your material. Click on the blend mode, and from the blend, change it from blend opaque to blend translucent. That makes your material look through, as you see here. And the lighting, change it to unlit. So now your material is basically unlit, so emissive node is available. You can change the emissive node of your material basically, which shows you the color or the texture of your material. It shines. And then the opacity channel you can change for your material to look opaque. Now just let me show you how the opacity works. So if you bring a constant value here, and the constant value is 0, your material becomes completely opaque. And if you make it 1, it becomes completely translucent. And if you make it something between 0 and 1, like 0.5, it becomes partially translucent. Now we set up a network that feeds into opacity to make the transparency of our material. We feed something into the distortion that makes our material have some sort of reflexive power or refraction power, and we make the networks for the normal channels and the emissive channels for the color of our material. Let's first set up our reflexiveness of the material. Because water is reflexive, we need to have this ability in our material. To make this material basically general for the fluid surfaces, we also will put a ability to kill out the reflection. So we create a parameter that lets us basically make our material not reflexive at all. So right click, and from the vectors bring a reflection vector. And the reflection vector is basically, if you look at the surface of your material, it is how at each point on the surface it takes the input of the light, and then it gets a reflection vector based on the input from the light. Now we need to transform this vector to a world coordinate. So right click, and then from vector operations bring a new transform operation. And if you click on the transform, you see that you have your source is tangent and your destination is world. Keep those as default. Now the next step is to bring a reflection cube map as a texture parameter cube map. Right click, and then from the parameters bring a texture parameter cube, texture sample parameter cube, and place it to the left of the transform, and get the vector transform into the UVs of this reflection. Now we need to apply a cube map to this texture sample that we created. Go to your generic browser, and then from the package that you have for chapter 2 of your volume 2, you will see that there's a cube water terrain cube map. Click on it, minimize your content browser, and then add the object from the content browser to the cube map. When you do that, this content will be added to your cube map. Let's change the parameter name of this to water cube, and then let's move it next to our object. Now, to be able to have an effect on the amount of reflection that we have, right click, and from parameters choose a scalar parameter and name it reflection string and make its value 1, and then multiply this reflection string into your cube map output. Okay, now if you add the output of the multiply into your emissive, you will see that now your material looks reflexive and emissive. Now let me just bring in so click on the plane, and I'll make it 1000 by 1000 and make it 24 segments. And I'm bringing the plane into the top of this water material that I created, alright, and create a additive brush. So the brush is placed a bit low. We'll bring it a bit higher so that it would stand as if I had an object here. And open your content browser, save the material, and so the water material that I have created, my water 1, select it and apply it to, let's make the plane just 1 by 1. So it'll have only one segment on it. Create an additive brush, and so here you will see that the water surface is applied on this material, and so we will have a reflexive component. However, actually, as you notice here, this reflexive component is basically looks like glass, so it's just completely opaque, doesn't have any transparency to it, but it's reflexive. So next I'll show you how you can set up your transparent network and also set up a color for your material. So let's drag all these components to the left, right click, from the parameters choose a vector parameter and call this vector parameter watercolor, or let's call it liquid color, and then apply a small color to it, and then multiply this color value to the output of your reflection color, and then apply your material. So your material will have a basic inherent color to it right now. If you play the level, you will see that your material is going to have a basic inherent dark color to it. Now, in order to set up some specularity on your material, we would basically recreate the specular component of our light. The specular component is the dot product of the light vector and a specular reflection vector, which eventually will be added to your final product, final network. So right click, and to bring a direction for the light, bring a vector parameter and choose the vector parameter as 0.5, 0.5, and 1, and then call it a light direction. This will allow you to specify the direction of the light. Right click next to it, and from the math, bring a normalize operation and get the RGB output of your light vector or light direction vector to the input of the normalize. Then right click above the component there, and from the vectors bring a reflection vector. Then right click, and from the math bring a dot product and add the output of your reflection vector and the output of your normalize operator to the input of the dot product. To make sure that this dot product stays between 0 and 1, bring two constant values and call one of them 0 and create the other one as the value 1. Right click, and then from the utilities bring a clamp operator, get the input of the dot product to the input of the clamp, 0 to minimum and 1 to maximum. And this will make sure that your final output is going to be between 0 and 1, the two dot products. Now you want to raise this output, which is your specularity, to a power. So bring another constant operator and put it as like 200 base, because water is highly reflexive. Right click, and then from the math operators, bring a power operator. Get the input of the clamp to the base and the 200 values to the exponential. Bring a constant value and give it a value like 0.5, or actually let's make it a specular color. So right click, bring a parameter, vector parameter, and call this vector parameter light specular reflection, and give it a value 0.5, 0.2, and 0.5 here, and then multiply the specular color to the specular power, and then finally add this value to your reflection. And replace your emissive power with this value. And as you see here, now you have a reflection that is kind of pink looking. Now I want it to look kind of like a sunlight, so we want to make it a yellow look. Now save your component, and if you play your level, now you will be able to see the specular component if you're looking at a direction of the light, which we don't have here. So as you see, the light is placed to basically apply at this direction to our object. Okay, now that we have our basic reflection set up and basic color set up, now we can go ahead and start talking about our opacity. Now for the opacity, if I just simply bring a constant value, and let's say I put it 0.5, then I can add that opacity to my material, and then when I play the level, as you see here, I can see through according to the opacity that I have set up. Now one thing that I had set up unintentionally is two additive levels. Let me delete the one that I don't need. And so here, without the opacity, my material looks like this. I deleted the entire thing. Let's just select the material, the plane, bring the plane in, and then create an additive level. Okay, now if I don't have opacity, as you see here, my material is completely, or if I don't have any transparency, my material is completely reflective and opaque. So this doesn't look water-like. If I add a certain number of opacity, or transparency rather, to my material, now my material is see-through, so it looks like glass, right? And so I can see through it. Now I can increase this opacity value to 0.75, make it more opaque, and so my material is more difficult to see through, but it is still reflective, as you see here. But on the other hand, it looks quite uniform. Now if you think about water-like surfaces, they essentially will have some sort of murkiness as the water becomes deeper and deeper. So the things that are closer to the surface of the water you see more clearly, so they are more transparent. And as the water depth becomes more and more, objects become more and more, or the water becomes more and more murky and becomes more and more opaque. So we need to have some sort of linear interpolation that we could interpolate between two base transparencies, one at 75 opacity and one at 25% opacity. So the objects that are deeper become more and more opaque. Objects that are closer to the water surface become more and more transparent, or become more and more visible. So for that, we will set up these two transparency components, and it would linearly interpolate between the two. So I get the 75.A and 25 0.25 opacity to input B of my linear interpolation. So now I can interpolate between the two, and I would like to interpolate between the two based on the two the depth of the objects. So right click, and then from the depth bring a destination depth, and that would become the bottom depth of the surface and right click and bring another depth, call it pixel depth, or from the pixel depth. Okay, and then next to the 2, right click and from math bring a subtract operator and subtract the 2 values, the destination depth and the pixel depth. And then we want to normalize this value. So we want to divide this value. From math, I bring a divide operator, and I divide the distance, the difference between the destination depth and the pixel depth with a base extinction parameter, and let's call it like 200. So any object that is farther than 200 is completely opaque, and any object that is between 200 and the surface will become more and more transparent. And then bring a clamp operator from utilities and clamp this value between 0 and 1. So bring a constant value 0 and another constant value 1. And so now this value ranges between 0 and 1 according to the destination and the pixel depths. Okay, and now we can use this as the linear interpolation between the 2 opacity values and give that to the opacity component here. So now the objects that are closer to the surface look less and less opaque and more transparent, and the objects that are farther become more opaque. Okay, now to show you how it actually looks like, let me bring another plane and let's apply a wood material, for example, to it. And let's place this plane at an angle inside this well, so we'll be able to better and more clearly see the differences. Okay, and then create an additive object, and then let's go and play the level. Okay, as you see here, the objects that are closer become less transparent, and the objects that are darker becomes more transparent. Actually, I may have placed these two in the wrong order, or maybe I have to put these the other way around. Okay, so it looks better now. So the object here, closer to the top surface, you see less transparent, more transparency, and as it goes down, you see the water becomes murky and murky, and down there it's a lot more opaque. So let's call this 95%. Okay, so here's how it actually looks like. This slanted object shows the exact idea here. The surfaces that are closer to the surface, to the water surface, becomes more transparent, and as it goes down, you see as it goes deeper and deeper, it becomes more and more opaque. Okay. So we set up our transparency here according to the depth of the objects, and we can increase this depth to say something like 400 to give it a better look. Alright, now if you look at this scene here, the water that I set up here, it actually looks like glass, of course, and still the pixels that I see behind the glass look pretty much the same as the pixels that I see in front of that glass, and it doesn't have any refraction component to it. You can set up refraction, and with the distortion node on your material here, as you see, if you manipulate this distortion node and create a network for creating your refraction, then you can make the pixels behind the transparent surface to get displaced a little bit along one direction in the three-dimensional space, and therefore you kind of change the look of or move the pixels that are behind your transparent surface around and give that sort of reflection look. Like for example, when you look through water, you will see pixels at the bottom of the water surface kind of displaced. So we can do that by setting up our refraction node. We can create a index of refraction parameter and an index of refraction constant to set this network up. So right click and then from the parameters bring a scalar parameter and call it index of refraction and give its value at 1.33. Bring another scalar parameter and give its value 1 and call it index of refraction constant, and then calculate the difference of these two. So from math, bring a subtract and calculate the difference of the two. And of course, we want to basically clamp this value. So right click, because we don't want a negative refraction. From utilities, bring a clamp and then bring a constant value at 0 and clamp this value so that you won't have a negative index of refraction. And then bring basically another constant value for your refraction multiplier. Give it a value like 12 and multiply the result of your clamp with the 12 index here. Alright, and then bring another constant and make this value smaller, like at 25%, and then multiply this 25% to the result of the clamp. So what happened at this point, let's go over it. We have two parameters. Then when we create instances, we can change those values. So we have parameter index of refraction and the index of reflection constant. We subtract the two, so at this point we have 0.33% here. And then we multiply that value to two different constants. Once with a larger constant, let's say 12, and one with a smaller constant, let's say 0.25%. So at this point we have two values, two floating number values, two integer values, two fractional values, and we want to create a vector out of these. To do that, we will basically right click and from the utilities we bring a new append value and we add the result of the first multiplied to a and b of the first append value. And here it creates a two-dimensional vector and puts the two constant values inside of it. Bring another append vector from utilities and then add the a to the first append and the b to the second multiplier. So right now the output that you have here is made of three values, a, b, and c. A and b are the same that came from the first multiplier, and b is different and c is different that came from the third multiplier. Now you can add the result of this network to your distortion value. And when you apply, right now you will not see much of a difference here. But if you apply the normal to this surface and multiply that with the refraction that you have here, then it will change the views of the material that you will see. We will set up the normals of your materials next.